July 21st, 2016. There's 3 or 4 things that I want to talk about in this video that are different from anything that I've seen in almost 5 years of doing these videos just on YouTube. But notice the timestamp, yesterday, 7/20/2016. You're looking at a diagram called the magnetosphere, and this is the Y cut. You see a black circle. Guys, many of you know what this is, but for the people that haven't seen these videos, the white circle represents our planet. This is really the Earth's shields. Inside that white circle, half of it is white to the right. That represents the sun-facing side of our planet. And the energy that's coming from the sun, from the right to the left in this image, goes past the Earth in this solar stream. Notice all the blue magnetic field lines are cut. Let's go back last month, June 16th, 2016, and this is more of a normal pattern. Again, the same image, different date. You've got the white dot in the circle, and everything was normal. But yesterday we started seeing some changes, and this was not the only one. I think it has something to do with this heat dome that we're experiencing right now, because we're seeing a lot of record highs. Let's just watch this, and we'll go through, again, starting yesterday. You can see if we go through the different stages as this comes in every few minutes. And again, what you're seeing not only in the black circle, but you're seeing satellites orbit the planet. Those are the GOES satellites, 14, 15, 13, and the Korean COMS. Also, the moon is depicted there. But notice your tilt here. Now we're up into the later hours of the 20th. Field lines are reconnected, but they're not quite right, guys. They're not streaming behind the planet. Now, I saw this twice before as far as this type of disruption, and it was usually followed by a magnetic field reversal. I'm not saying that's what's going to happen this time, but this disruption. But we are getting smaller flares that are intense, and the Earth magnetic field has changed in the last few days as far as the magnetic connectivity point between the Earth and the sun. Now, look at these 2 images. One last month going back to the 18th of June, and look at the angle of the blowback from the sun. You see where I've got the arrow, and I've got it centered on both of the closed field lines, which are indicated in red. Now, let's go to now on the right. You see the difference in the angle of magnetic field lines? Now, I know this shifts periodically, but to do it this fast and to be this chaotic, there's a reason for it, and I'm going to show you in just a few minutes. We'll go to that Earth-Sun magnetic connectivity chart. But guys, if you've seen my videos in the past, I always put that red line there. If we're looking at the magnetosphere as a average, and that's called a standoff point. Notice it's at 12 on the indicator below, and you'll see it fluctuate back and forth under extreme conditions. If CERN's running extremely high with a lot of solar activity that they are taking advantage of as it increases the energy in our magnetic field that travels through our planet, you will see this collapse and bend and distort. But now, notice that I've gone back to June 18th, 2016 to give you an average, because now it is not average. Again, we're going through a solar minimum. We've seen very little reaction on our magnetopoles with CERN, and I think it's because that they rely heavily on the sun's energy. They capture that energy, and guys, it would take this video 30 more minutes for me to explain the Hall currents and how that energy is fed down into the field currents and the ground currents of our planet. But I do have several videos that explain it in detail. But again, notice now we're going to go into the 20th, and the standoff is extremely to the outside. And the burn-off patterns are not to the back, but they're going from the top to the bottom. Look at this. You see at the bottom center of this image, normally that burn-off would be either to the top, maybe with an angle, or to the back, but never both ways. But look where it's staying at. We're going, again, watch your timestamp, starting yesterday, goes back to average here, but look at the disruption to the left of your screen, again, going through that side burnout pattern, and instead of compression, we're having a disruption in the angle of the field, and that's what we're seeing here with these satellites. Now we're out near 15. It never stays out there. If it ever, you may see it on a bounce from an extreme compression event, but we're into the 21st. Look at that. At 15, and it's been holding there for hours. We're going into the last timestamps. Solar activity is at an increase. These are not X flares, but compared to the flat line that we've seen most of this year, those two sunspots that we've seen rotating are having an effect. We'll look at that. You can see in the magnetic field disruption, almost at the bottom, a complete reversal of where the magnetic field, how the way it's aligned. And we're looking at 8 satellites, and this gives us a warning. This is placed between the Earth and the Sun to give us this type of information. You can see in the protons, it's coming off about 3 bursts there, and both electrons and protons. Even in the magnetometer, guys, and this has to do with ground currents, things like that. On just after midnight on the 20th, we saw that spike. After that, we saw a compression event on the Sun, and then this outward movement of our magnetopoles has to do with the angle. But watch the Sun going back a few days. What you saw there was an adjustment on the satellite. But in these frames, these are the flares that I'm talking about. These are the 2 sunspots we've been watching for a couple weeks. And you'll see the flares as it stabilizes. Again, you're seeing movement from the satellite cameras. And I've seen this several times. They'll do it a couple times a year. Sometimes after an extreme flare, they may slightly tilt the satellite, and they readjust it. It has almost like an automatic balancing system. But here are the flares that I'm talking about. You're going from right there, and those aren't X flares. We've seen them like that, but the last flare, and I'll pause it on that, didn't get to an X flare, but it was long enough and strong enough that we felt that pulse. I'll stop it at that point. Let's go back. You've seen it many times. This is another satellite called the Solar Dynamics Observatory. But it was so bright at that point, right here at the 21st at 12:58, that's today, UTC time, it overrode the optics inside the cameras of the Solar Dynamics Observatory. Again, this satellite is like the ace. It's between us and the Sun. It gives us that perspective. These 2 sunspots, pay attention to where they're at. You see that? Now, what you're looking at now is from the 13th of this month. Notice your timestamp at the bottom. Top right, 2 dots, orange and blue. That represents the magnetic connectivity point between Mars and the Sun and Earth and the Sun. Notice the chart in the bottom right. It gives you the color coding. In 7 days, notice how far that connectivity point dropped. Remember the tilt I showed you in the magnetopoles, how it went from not quite a flat angle, but it dropped steeply? This is why. You're not seeing Earth under the brown dot because Mars, they're on top of one another, and Mars is on top of the blue dot because it's further out of the solar system. Now in 7 days, they've dropped right between the 2 sunspots. The magnetics in that sunspot were strong enough to pull the magnetic connectivity point downward. Doesn't tilt the physical Earth, but it has tilted the magnetic field around the Earth, and that's where the energy feeds in. We're tilted further south. We're having record heat. Now, this tilt will do the same thing in the winter. As we look at CERN, now it's come down off running record power for records amount of time, but they're starting to power back up. Notice your energy is just at 0.45 tera-electron volts at the timestamp now as I'm doing the video, but it's been running at very high power for record lengths of time. Is this part of the effect? We're dealing with the magnetics. Now, here's what we got, a massive dome with high pressure. It's a little further south. I know it's hot, guys, but we're breaking records all the way across the map. And this is called an atmospheric heat dome. It says there's been a couple of high-pressure ridges aloft, which are called bulges in the jet stream, that have prevailed across the U.S. One ridge now is positioned around the western U.S. and the other in the southeast. We got 2 sections because they're connected. The western ridge has occasionally expanded a bit more to the north and east, while the south southeast ridge, which is Mississippi area, Florida, has expanded north and west, but only for short periods of time. As this week progresses, we will see a bridging of these two ridges, resulting in one massive dome of high pressure. Guys, you've got to be very careful and keep yourself cool and hydrated. A heat stroke is nothing to play with. Believe me, I've been there. Look at the current fields. This was last night at 7 p.m. That, on this map, it should be much cooler than that by now. It may have something to do actually with the lack of protest in this heat at the Cleveland Republican Convention. If you saw any of the videos today, there were a lot of protesters that tried to get started, but the police kept sending them in the square around the certain blocks and keeping them moving in that heat, and they were just worn down, man, and it was a pretty slick move. But again, you're looking at Palm Springs, Los Angeles, guys. That's for Friday through Sunday. Look at these temperatures. Nothing to play with. Now, it's a little drier in the west. You get in this heat further in the southeast, you have that humidity, but it's going to be hot. Again, the beams are small here right now at 0.45 tera electron volts. But when they kick this thing back up to 13, you'll see them tighten up into tiny dots. The change we're going to see coming this fall is that right now we're seeing proton to proton collisions, each in this large underground collider. They're going to change that from proton to lead on one side collisions, guys. If you know anything about that, it changes the chemistry of everything. Now, again, we're coming off record periods of time. Look, from 0500 to 2300 hours of constant power, 13 tera electron volts, luminosity holding in there. So the magnetic field that surrounds our planet, that's connected to that long plasma tube that connects to the sun, is also connected to CERN. It lays right within what's called the ground current zone of our planet. And you get two magnets close together, their coils interact. Now, what we've seen so far with this disruption, the only unusual quake is the 4.0. It's 19 kilometers southeast of Bayside, California. There's, to me, when I see these quakes, you have inward pressure, but you can associate it, guys, with the Cascadia fault zone. When you go offshore, directly west from this area, you're right at the bottom of that pressure. See off Eureka right there? So usually in Northern California, these type quakes are related to pressure, again, on the Cascadia fault zone. We've done many videos about that. You've got the 5.3 in Tonga and all. You see that in these active regions. But the 4.7 in or 4.8, excuse me, is not that usual for that area. We see a lot of 2H, 3s and all. But watch that area and watch Cascadia. Again, the heat dome, guys, is going to be pretty rough this week. It's a heads up. Be safe.